So welcome to the limits series of the maths module. This first episode we're just going to discuss sort of what limits are, like with most of the different series, and then the following videos we're going to show you different ways to tackle other limits, where some problems may arise and how to deal with the problems. So limits may be a new concept to quite a lot of people, and this hopefully will help. So the notation for limit to start with. If we have a limit of some function, it's normally given as this, and our function will be a function of x. If you don't know what I mean by referring to it as a function of, see my function series. So it's a function of x, and we're going to have, say, x plus 2 minus... In fact, we won't. We'll just do it like that. We'll just have x plus 2 for a start. It's a nice simple one. But it has an arrow saying as it approaches, and we will give a value, in this case, of 1. So what a limit means, the way one of my lecturers explained to me once was, he explained it like if you were getting closer to a wall, and this wall is the value, and this wall in our case is a value 1. And our value of x is getting closer and closer and closer to this wall, which is 1, but it never quite reaches it. There's always just this tiny, tiny small gap between your value of x and 1. It's an infinitely small gap. It's 0 point, an infinite amount of noughts, 1 difference between your value of x and the limit it reaches, but it never quite reaching it. And this is important when we consider if we have a limit going to infinity, because infinity is not a value, but we're always approaching it, and also if we're approaching 0, because if we had some function of, say, 3 over x, and we have a limit of x going to 0, you can't divide by 0, but you can divide by almost 0. Right, so that's how it's noted, and that's the way to think about it. We're always getting closer to the value, so close we can consider it that value in some cases, but we never actually reach the value. So we'll take our limit we've just took here of a limit of as x approaches 1 for the function x plus 2. So when we've given a definite value which isn't 0 or infinity, and it's a limit we don't think we need to do anything else to for a start, we can solve this by putting in the value of 1 into x and plus 2, and we just get 3. Really is that simple for basic ones. And what this tells us is that as x goes to 1, our function of x goes to 3. So it's not an equals. We don't say... You will see people say this equals 3. In an exam, you may get given a mark for that. You may say it's correct. But what we're actually determining here, what we've actually found, is that as x gets closer to 1, f of x gets closer to 3. But because we never reach 1, that never actually reaches 3. So this is technically invalid. Technically. But most people will treat it as that. We'll give another example of another limit, and we can say, what limit should we take? Z approaches 0, and we have a limit of x squared plus 2x plus 4. So now we can put in 0 squared plus 0 plus 4. So that means a z goes to 0, f of z goes to 4. Now for a lot of this I will be using just this notation of the limit, the function, and equals the value. So I might write this as the limit of z to 0 of x squared plus 2x plus 4 equals 4. I'll write that, remembering always that we actually have to put as z approaches 0, f of z approaches 4, but it's just faster to just write equals 4 when we're just giving demonstrations. Right, so that's all we're going to discuss for the introduction into limits. Next, we're going to be looking at how to deal with limits of 0, limits of infinity, and limits of minus infinity. And from that, we'll discuss how to deal with some more complex limits, where we have to deal with if we've taken something to 0 or to infinity, what's the best way to treat that, and also how some limits can be approached from different sides.